Yeah, so this video is about the fundamental counting principle. This is a really easy way that you can use to determine how many ways you can arrange items. Let's look at an example. So the question is, how many ways can Hope, John, and Asada enter a classroom? So let's think about this. You got 3 students, Hope, I'm using H for Hope, J for John, A for Asada. So you got the first person, second person, and third person in order. So the first person, it could be Hope. Next person could be John. Next person could be Asada. And that's one way. Or you could have had for first, second, third. You could have had John first, and then Hope, and then Asada. So you can see we keep coming up with lots and lots of different combinations of this. So essentially, what we're going to have is this many ways. We look at it this way. The first person, we have 3 options for that first person to come in. It could be Hope, it could be John, it could be Asada. After one of those people have come in, how many options do you have left for the next person? Well, you only have 2 options left there. And then after that person come in, you only have 1 option left. So what it really is 3 times 2 times 1. So 3 times 2 times 1 is 6. So there are 6 ways. There are 6 ways. All right, that they can come in. And we can find all 6, but that's our way of finding it. And this is essentially the fundamental counting principle. I'm basically figuring out how many different ways different objects can be arranged, or different people can get first place and so forth. All right, so that's one example. I'll give you another example. How many ways can you arrange letters in the word micro? Let's first see how many letters we have. We have 1, 2, 3, 4, 5 letters. 5 unique letters. By unique, none of the letters are the same. So if that's true, you need 5 blanks. So this is the first letter, second letter, third letter, fourth, fifth letter. So the first letter, it could be M, it could be I, it could be C, it could be R, or it could be O. It could be any of those. So truthfully, we have 5 different options for this first letter. 5 options. After we actually use that letter, we don't have any more options. So we've got 4 options there. After you use that letter can't be used again. So now we've got 3 options. And then 2, and then 1. So essentially what this is 5 times 4 times 3 times 2 times 1, which is 20 times 3 is 60 times 2 is 120 ways of arranging micro. All right, that's 120 ways. Basically, we ever see this 5 times 4 times 3 times 2 times 1, there's a name for that. This is 5 factorial. Oh, this symbol means factorial. Basically means all the factors of 5, all the numbers that led you to 5, all the integers that led up to the number 5. So 5 and then this exclamation point means factorial. If you ever see that, that means 5 times all the integers down to 1 that led you to that. All right. Another example of factorial. Oh, if you want that as a note, I'll copy this down. I'm about to erase it though, but I will get that down as a note if you want. All right, the first one says 3 factorial. Basically, it means it's 3 times 2 times 1, which is 6. So that's what 3 factorial is equal to. 3 factorial equals to 6. 6 factorial basically means 6 times 5 times 4 times 3 times 2 times 1. I already know this is 120. Basically 6 times 120. 600 plus 120, 720. That's what 6 factorial is. The next one is 7 factorial divided by 5 factorial. I would expand the top number, and you're going to see something happens really nice for you. 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. Well, what does 5 over 5 reduce to be? Well, all this has been multiplied together, and all this has been multiplied together. So I can really divide these off, and they divide out to be 1. And then these 4s divide off also to be 1. And these 3s divide away to be 1. And these 2s divide away to be 1. And these 1s are already 1. But they also divide away to be 1. So basically what you get is 7 times 6 times 1 all over 1. So it's basically 7 times 6 over 1, or just simply 42. So 7 factorial divided by 5 factorial is just simply 42. All right. Another example. All right, so anyway, I would copy that down if you want. I'm going to erase the screen again. All right, so in this section, we're going to talk about when repetition is not allowed, as in letters that are repeated, and you don't want to have the same word because you have the same letter, just a different place. All right, basically what I'm trying to say is this. How many ways can you arrange the letters in the word these? All right, so let's look at this. You got 1, 2, 3, 4, 5 letters. 5 letters, but they're not all unique. The E's are the same letter twice, so 2 E's. You want to take into account all the letters that get repeated. All right, so basically what we're going to have this time is, since you got 5 letters, there are 5 factorial ways of rearranging them. But I got to divide out the ones that repeat. So I got 2 E's that repeat. I'm going to divide that by 2 factorial. So basically, our number of ways is going to be 5 times 4 times 3 times 2 times 1, divided by 2 times 1. 2's cancel. Give you 5 times 4 times 3. That's 20 times 3, so that's 60 ways. You can arrange that so that you have different words. And again, we have to divide out the E's, because if you wrote E, T, H, S, E, we're using the first E. They rearrange with the second E. E, T, H, S, E. Well, you can't tell which one is the first and which one is the second E. So technically it's the same word because there's no distinction between which E you used. So because of that, we got to divide it by the ones that got repeated. All right, so I'm going to give you another word. How many ways can you arrange the letters in the word reference? All right, so I'm going to pause the video and let you actually see if you can do it on your own. And after you get done, see if your answer matches mine. So pause the video and see if you can actually figure out how many ways you can rearrange that word. And afterwards, we'll talk about it. All right, so if you gave it a shot, you probably first counted the number of letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters in the word reference. And which ones repeat? So you got an E, another E, another E, and another E. So 4 E's. Are there any other letters that repeat? All right, there's only one F. There's an R. So we've got an R here, we've got an R there. So we've got 2 R's and 1 N and 1 C. So that's it. That's all the letters that repeat. So the answer should be 9 factorial divided by 4 factorial times 2 factorial. And that reduces the B. 9 factorial is a really big number. There's a button for factorial on your calculator. I'm going to show you where it is. All right, pull out your TI. You can type in that. So let's actually go there. If I want to type in 9 factorial, this is what you do. You type in 9 and then hit math, then go over to probability. 1, 2, 3, 3 clicks over probability. If you go down to this number 4 here, you're going to see your factorial. So enter. So you get 9 factorial. So hit enter there. It gives you 362,880. So this is 362,880 over 4 factorial. Well, that's 4 times 3 times 2 times 1. So 6, 12. 4 times 6 is 24 times 2. Do all the math there. You should eventually come up with 7560. All right. So that means it's ways. All right. So you got 7,560 ways you can rearrange letters in the word reference without anything being repeated, without any words being repeated. All right. Moving on to the next example. Oh, but yeah, I would write down anything that you didn't already know how to do. All right, so there are 14 switches on a fuse box. Any fuse box inside your house, whatever. How many different arrangements are there? So you think about this. This is a fuse box in your house, and you only have 2 options for each switch. Either it's on or it's off. It's the only option you have. Just come up with 14 blinks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And either this could be on or it could be off. So I only have 2 options. So I got 2 options for the first blank. It didn't say that they have to change if the first one was on, the next one has to be off, whatever. So I got 2 options for the next blank and 2 options for each blank. So basically 2 times 2 times 2 times 2, 14 times. So basically 2 to the 14th. So technically you leave this 2 to the 14th. Or you plug in and calculate 2 to the 14th. And you get the value of that. That value is 16384. 16384. Make that 14 look a little better. So 2 to the 14th power. Still good. Anyway, so that's 16,384 ways you can rearrange this fuse box. All right, so I think that's about it. That's all I have. Good luck.